class in Mathematics of Investment. For today, we will take up another type of annuity known as deferred annuity. And today we will also take up perpetuity, the two types of perpetuity. The normal perpetuity and the other type of perpetuity where the regular payment increases at some growth rate. Now, in deferred annuity, there is also a regular payment denoted by capital R, and the regular payment may be made either at the beginning of each period or at the end of each period. When the regular payment is made at the end of each period, the accumulated value of deferred annuity will make use of ordinary annuity. And if the regular payment is made at the beginning of each period, then the accumulated value of the deferred annuity will make use of the annuity due. That is, if the regular payment is made at the beginning of each period, the deferred annuity will be treated as annuity due. But there is a difference between the formula for ordinary annuity and deferred annuity, where the payments are made at the end of the periodic intervals. And there is also a difference between the formula for deferred annuity, accumulated value of deferred annuity, where payments are made at the beginning of each periodic interval, and the formula for annuity due. Now we write the formula for calculating the accumulated value of deferred annuity when regular payments are made at the beginning or at the end of each periodic interval. If in deferred annuity, the regular payments are made at the end of each periodic interval, then that annuity will be treated as ordinary annuity. But the formula for computing the accumulated value of the deferred annuity is given by this formula. Accumulated value denoted by A is equal to capital R, the regular payment, multiplied by quantity 1 minus quantity 1 plus I to the minus n, all over quantity 1 plus I to the power t times I. And here is the number of regular payments, or the number of periodic intervals, or the number of periods. And I is the interest rate per period. And here is the number of periods that the payments will be deferred. If in deferred annuity, the regular payments are made at the beginning of each periodic interval or at the beginning of each period, the accumulated value denoted by capital A is computed by this formula. A equals capital R, R is the regular payment, times quantity 1 minus quantity 1 plus I to the minus n, all over 1 plus I to the power t minus 1 multiplied by I. And it's obvious by inspection of these two formula that the only difference between the two formula is the exponent of 1 plus I in the denominator. For ordinary annuity, that means we have a deferred annuity but regular payments are made at the end of each period. The exponent of 1 plus I is t. But if in the deferred annuity, the regular payments are made at the beginning of each period, the exponent of 1 plus I in the denominator is P minus 1. Now, in deferred annuity, the first payment is deferred or delayed for some periods or for some intervals. If the regular payments are made annually, yearly, or each year, the first payment in deferred annuity is deferred or delayed for some years. That means you do not immediately pay the regular payment R. You will have to pay it after some periods at some later time. And the number of periods that the payments will be deferred or delayed is denoted by T. T is the number of periods or the number of payments that will be deferred or will be delayed. Now, examples of deferred annuity is that you make a lump sum deposit or you make a lump sum investment today, and then after some years, say after 5 years or after some like 10 years, you will receive a regular payments as your earnings from your investment that you make today with a large amount of money. And also if that's usually what is used in educational plans or in retirement plans. Also, if you receive a loan, a certain amount of loan today, and you have to repay it after 5 years or 3 years with a regular payments including interest, then that's an example of deferred annuity. We will now take some examples for using this formula to compute the accumulated value of deferred annuity. For our first example, consider the following problem. Miss X deposited a certain amount today and will receive 30 annual payments of 5,000 pesos each. The annuity will start 4 years from today, and the applicable rate of interest is 5%. What amount of money was deposited today by Miss X if the annuity payment is supposed to be made at letter A, the end of each year, and letter B, at the beginning of each year? In this problem, Miss X made a lump sum payment, a lump sum deposit today, but this amount is unknown, and that is what we want to find in this problem. And in return, Miss X will receive a regular payment of 5,000 pesos each year for 30 years, 30 annual payments. But Miss X will not receive 5,000 pesos not until 4 years have elapsed. That is, the first payment will be deferred or will be delayed for 4 years. From today, Miss X will not receive any payment for 4 years, but will receive the first regular payment after 4 years, and that's the end of either the end of the beginning of the 5th year or at the end of the 5th year. And regular payment will include an interest computed at the annual interest rate of 5%. Now we write the given information. Capital R is the regular payment that Miss X will receive, and capital R is 5,000 pesos. The regular payment will include the annual interest of 5%, and we always convert the interest rate in percent to decimal number. Hence, 5% is 0.05. Now, Miss X will not receive payments for 4 years. Hence, the number of deferred payments or the number of periods that Miss X will not receive payment is 4 years. T is the number of deferred payments, which is 4, because Miss X will not receive any payments for 4 years. And N is the total number of regular payments that Miss X will receive. And it is given that Miss X will receive 30 annual payments, and that's a small letter r. If in letter A, Miss X will receive the regular payments at the end of each year, then we treat this deferred annuity as annuity due. And the formula to calculate the accumulated value of this deferred annuity is given by the following formula. Accumulated value of this deferred annuity with payments made at the end of each year is given by the following formula. A for accumulated value is equal to R times quantity 1 minus quantity 1 plus I to the power minus N all over 1 plus I to the power T times I. This is the formula to use when the regular payments are made at the end of each year. Now we substitute the given. Capital R is 5,000 pesos. Multiply by 1 minus quantity 1 plus I. The interest rate per period per year is 0.05. To the power negative N. N is the number of total regular payments, 30. All over 1 plus I. I is 0.05 to the power T. T is the number of deferred payments, 4. Multiply by the interest rate per year. And we compute this direct in our calculator using our scientific calculator. We start with 1 minus 1 plus 0.05 to the power minus 30. 1 plus 0.05 is 1.05. We write 1 minus 1.05 to the power negative 30. And multiply by 5,000 pesos. And divide by 0.05. And divide again by 1.05 to the power 4. And to 2 decimal places, you should get 63,234.77 pesos. Thus, if Miss X is to receive 5,000 pesos at the end of each year for 30 years, because she will receive 30 payments annually, so that's 30 years. And if she will receive 5,000 pesos at the end of each year for 30 years, she has to deposit 63,234.77 pesos today. Now, if Miss X will receive the same amount, 5,000 pesos, but she will receive it at the beginning of each year, we calculate how much Miss X has to deposit today, and we treat this annuity deferred as annuity due. The accumulated value of annuity deferred if payments are made at the beginning of each year, at the beginning of each period, is computed by this formula where A denotes the accumulated value is equal to R, the regular payments, multiplied by quantity 1 minus 1 plus I to the power minus n, all over 1 plus I to the power t minus 1. We subtract 1 from the number of deferred payments, multiplied by the interest rate per period. In this example, the interest rate per year. So we substitute the given data. I is 0.05 and N is 30 and T is 4. We substitute the given information. Capital R is 5,000 pesos. Interest rate per year is 0.05. N is the number of payments, regular payments, 30. And T is the number of deferred payments, 4 minus 1. Again, we find this value using our scientific calculator. And 1 plus 0.05 is 1.05 and 4 minus 1 is 3. We start with 1 minus 1.05 to the power minus 3 and multiply the result by 5,000 and divide the result by 0.05 and divide again the result by 1.05 to the power 3. We have 1 minus 1.05 to the power negative 30. And the answer multiplied by 5,000. Press equals. And the answer divided by 0.05. Press equal. And the answer divided by 1.05 to the power 3. And you should get 66,396.51 to 2 decimal places. Thus, if Miss X is to receive 5,000 pesos each year for 30 years, she has to deposit 66,396.51 pesos today. And after 4 years, she will start to receive 5,000 pesos at the beginning of each year for 30 years. So you can see from the results that Miss X will have to deposit a larger amount if she wants to receive 5,000 each year after 4 years for 30 years at the beginning, and she will receive 5,000 at the beginning of each year. For our next example, consider the following problem. Mr. Y received a deal to loan 60,000 pesos today, and in return he will get 25 annual payments of 6,000 pesos each. The annuity will start 5 years from now, and the rate of interest is 6%. Determine whether Mr. Y should accept or reject the deal. If the payment is A, an ordinary annuity, and letter B, the payment is an annuity due. In this problem, there is a proposal to Mr. Y that he loan his money amounting to 60,000 pesos. And as payment for this loan, he will receive 6,000 pesos each year for 25 years because there is 25 annual payments, and the first payment will be received by Mr. Y after 5 years. So there will be 5 deferred payments. Payment will start only after 5 years. That means Mr. Y will receive the first payment on the 6th year, either at the end or at the beginning of the 6th year. And we want to find out if this is a feasible proposal or deal for Mr. Y. If the payment, letter A, is an ordinary annuity, that means Mr. Y will receive each payment at the end of each year. And letter B, the payment is an annuity due, that means Mr. Y will receive each payment at the beginning of each year. We now write the given information. The regular payment amounts to 6,000 pesos and is denoted by capital R. The interest rate is given 6%, so we take this as the annual interest rate. In decimal number, that's 0.06. And the number of regular payments that Mr. Y will receive is 25 regular annual payments. And that's denoted by small n. But he will not receive the first payment unless 5 years have elapsed. Therefore, the number of deferred payments is 5, denoted by small t. In letter A, the payment represents an ordinary annuity, and the accumulated value denoted by A is computed by the following formula. If the payments are to be received by Mr. Y at the end of each year, because the payment is an ordinary annuity, accumulated value A is given by R multiplied by quantity 1 minus quantity 1 plus I to the power minus n all over quantity 1 plus I to the power t multiplied by I, where I is the interest rate per year. We substitute the given information. Capital R is 6,000 pesos. Capital R is 6,000 pesos. The interest rate per year is 0.06 to the power minus n is 25. And T, the number of deferred payments is 5. And 1 plus 0.06 is 1.06. And we compute this value using our scientific calculator. We start with 1 minus 1.06 to the power minus 25 and multiply the result by 6,000 and the result divided by 0.06 equals, you press equals in your calculator and the result divide again by 1.06 to the power 5. We have 1 minus 1.06 to the power negative 25. Press equals and multiply the answer in your calculator by 6,000 pesos. Press equals and the result in your calculator divide by 0.06. Press equals again and the result in your calculator divide by 1.06 to the power 5. And you should get to 2 decimal places 57,314.80 pesos. Thus, if we get the sum of all the payments, the regular payments of 6,000 pesos for 25 years, and that includes the interest, the accumulated value of these 25 regular payments of 6,000 pesos each, including interest, would amount to 57,314.80. And this would be the payment for the loan of 60,000 pesos. So we conclude based from this result that this is not a feasible deal or proposal for Mr. Y, because if he agrees to loan his money, 60,000 pesos today, he will lose some amount, because in return, in payment for the loan of 60,000 pesos, he will only get a total of 57,314.80 pesos from a regular payment of 6,000 pesos each year for 25 years with interest at 6%. So we recommend to Mr. Y to not accept or to reject the proposal or the deal. Now we answer letter B. We again determine if the deal or proposal is feasible for Mr. Y if the payment is an annuity due. That is, the loan, the repayment of the loan will be made by regular payments of 6,000 pesos at the beginning of each year for 25 years. And the formula to calculate the accumulated value of deferred annuity with regular payments made at the beginning of each year is denoted by capital A and is given by this formula. A equals R times quantity 1 minus quantity 1 plus I to the power minus N all over 1 plus I to the power T minus 1 multiplied by the interest rate per year. In this example, it's 0.06. Again, we replace R, I, N, and T with the given data. The regular payment capital R is 6,000 pesos. The interest rate per year or per period is 0.06. The number of payments to be made at the beginning of each year is 25 regular payments. And the first payment will be deferred for 5 years, so T is equal to 5. For annuity due, for annuity deferred with payments made at the beginning of each year, we subtract 1 from T. We have 5 minus 1 multiplied by I, 0.06. Again, we compute this using our scientific calculator and we start with 1 minus 1, 0.06. 1 plus 0.06 is 1.06 to the power minus 25. And the result multiplied by 6,000. Press equals in your calculator and divide the answer by 0.06. Press equals again your calculator and divide again the answer by 1.06 to the power 4. 5 minus 1 is 4. We have 1 minus 1.06 to the power negative 25. Press equal in your calculator and press equal sign, the equal sign in your calculator and multiply the answer by 6,000 pesos. Press equals again and multiply the result by, divide the result by 0.06. Press equals and divide again by 1.06 to the power 4. And you should get 60,753.69 pesos. Now, if Mr. Y will receive the regular payment for the loan of 60,000 pesos at the beginning of each year for 25 years, that includes the annual interest of 6%, he will get a total of 60,000 pesos 753.69 as payment for the loan of 60,000. Since this is greater than the loan of 60,000 pesos, we say that the deal or the proposal is a feasible one for Mr. Y. And we recommend to Mr. Y to consider the proposal or the deal for an earning of 60,753.69 minus 60,000 pesos or 753.69 pesos. Now we take another type of annuity known as perpetuity. In perpetuity, the regular payments are made indefinitely. That is, the regular payments is made without end. In perpetuity, there is a regular payment that is fixed, and this regular payment will be received for each period for each interval, but we do not know when the regular payment will end or will terminate. And so perpetuity is a type of annuity, except that there is no definite time when the regular payment will end. And so for perpetuity, we can not calculate the accumulated value of a perpetuity because we will never know exactly what is the number of regular payments to be made because the time uh, the time of payments is not known in perpetuity. And but we can calculate the present value of a perpetuity. We can calculate all the values of the regular payments at present time or today or now. And the formula to calculate the present value of a perpetuity is given by the following. The formula is quite simple to remember. Present value of a perpetuity is equal to capital R, the regular payment, per period, divided by the interest rate per period. For our example, consider the following problem. Natalie receives 25 pesos each month for a stock she bought that pays 3% interest annually. What amount will Natalie receive if she wants all her earnings now? In this problem, Natalie bought a stock and we do not know exactly how much she paid for that stock, but it must have been the amount must not have been a large amount because she's only receiving 25 pesos each month as earning from that stock she bought, but this stock pays an interest of 3% annually. And now Natalie wants to get all her earnings today. How much will she receive? In this problem, the amount of 25 pesos that Natalie receives is being paid to Natalie indefinitely. The problem does not specify when the payment of 25 pesos will end, so we consider this problem as a problem on perpetuity. That is, Natalie will receive 35 pesos each month as long as she is still alive. And now we calculate how much she will receive today if she wants all her earnings today. If she wants to get all her earnings today, rather than receiving 25 pesos each month. And capital R, the regular payment each month is 25 pesos. Small I is the interest rate per period, and the given here is 3% interest annually. Annual interest is 3%, so we divide that by 12 to get the interest rate per month. We divide 0.03 by 12 to get the interest rate per month because 3% is given as the interest rate annually. The annual interest rate is 3%. So we divide that by 12. And 0.03 divided by 12 is 0.000025. Let us check. .0025. And the present value, the amount that Natalie will receive today, is obtained by simply dividing R by the interest rate per period. .25 is R, I is 0.0025. And we divide 25 by 0.0025. And you should get 10,000 pesos. Thus, if Natalie wants to get all her earnings from that investment in a stock that pays 3% annual interest, she will receive 10,000 pesos today. And this is the first type of perpetuity. It's called the normal perpetuity. The other type is one in which the regular payment increases at every year or every period. From one period to another, the regular payment increases at a constant growth rate. And for the type of for the type of perpetuity, the present value of the perpetuity is given by the following formula. Again, the formula is simple for calculating the present value of the second type of perpetuity, where there is a regular payment and the regular payment increases from period to period at a constant growth rate denoted by G. This is G%, I is the interest rate per period. And the present value of that second type of perpetuity is equal to the regular payment divided by the difference between the interest rate and the growth rate. For our next example on perpetuity, consider the following problem. It is stated in the will that Nina is to receive a monthly allowance of 10,255 pesos with interest at 2.5% per year. It is further specified that allowance should increase at 1.75% annually. Nina wants to get all her money now. How much will she get? In this problem, someone has left Nina a certain amount of money and deposited the amount in a bank that pays an annual interest rate of 2.5%. And it is stated in the will that Nina will get from this fund or money deposited in a bank and an annual allowance of 10,255 pesos. We take this as annual allowance because it is further specified in the will that the allowance should increase by 1.75% annually. So 10,255 must be the annual allowance, must be an annual allowance. Now, Nina wants to get all her money now. Instead of getting 10,255 pesos every year, indefinitely, it is not specified when Nina will stop receiving 10,255 yearly. So we take this as a problem on perpetuity. And we now calculate how much Nina will receive today if she gets all her money now. And the formula to calculate the present value of a perpetuity with regular payment increasing at a regular growth rate of denoted by G is given by the following formula. The present value of a perpetuity with regular payment that is increasing at a constant growth rate of G is given by P equals R all over 1 minus G, where R is 10,255 pesos annually. And the amount deposited in a fund or in a bank earns an interest of 2.5% per year. In decimal, this is 0.025. And the will specifies that the allowance should increase by 1.75% annually. And so this 1.75 is our G in this formula. And we convert 1.75% to decimal by dividing it by 100, or simply moving the decimal point 2 places to the left, and we get 0.0175. And we substitute the given information into this formula. P is equal to R, 10,255. Divide by I in decimal number 0.025. Minus the growth rate at the rate at which the allowance increases every year, 0.0175. And we calculate this value using our scientific calculator. We have 10,255 divide by 0.025. Use an open close use an open parenthesis, minus 0.0175, and then use a close parenthesis and press equals. You get 1,367,333.33. Hence, if Nina will get all her money now, instead of receiving 10,255 pesos annually, she will get this amount today, 1,367,333.33 pesos. And this will make Nina an instant millionaire. And that completes our lesson on perpetuity. And the last word for our last word, you should note that this formula would work only if the growth rate or the rate at which the regular payment increases per period from period to period is less than the interest rate I. Again, this formula for calculating the present value of a perpetuity where the regular payments increase at a constant rate of G will only work out if interest rate I is greater than the growth rate G, or the rate at which the regular payment increases from period to period. For your practice, please try the following exercises. Number 1, Liam receives a proposal to make an investment of 300,000 pesos today, and he will get 8,500 pesos monthly for 20 years. If payments are deferred for 3 years and the applicable interest is 1.65% per year, should Liam make the investment if he gets each payment at letter A, the beginning of each month, and letter B, the end of each month? In this problem, Liam is considering making an investment, and the amount to invest is 300,000 pesos. And in return for this investment of 300,000 pesos, he is promised to receive 8,500 pesos each month for 20 years. But the first payment will be deferred for 3 years. That is, Liam will receive only the first payment after 3 years have elapsed. and this money investment will earn an interest of 1.65% per year. Now, in letter A, if Liam is going to receive a regular payment at the beginning of each month, will he make the investment? In letter B, if Liam will receive the regular payment at the end of each month, will he also, should he also make the investment? Number 2, Windsor will receive 795 pesos each month with an increase of 1% each year from a fund that pays 3.25% interest. So this is 3.25% annual interest. As we have taken in the past lesson, if the interest rate does not specify whether it is an interest per year or interest compounded annually, semi-annually, quarterly, or monthly, we take it as an annual interest. So we take 3.25% interest as an annual interest rate. If Windsor decides to get all his money now, how much will he get? Now, it is not specified in this problem whether when the last payment of 795 pesos to Windsor is going to be. So we take this as a problem on Perpetuity case 2 because the amount that Windsor will receive, 795, will continue to increase every year at the rate of 1%. And now Windsor wants to get all his money now instead of getting 795 pesos each month. How much will he get? And that completes our lesson for today on deferred annuity and perpetuity. If you have a question about the lesson today, you ask your question in the comments below. And thank you for joining me in my class today in Mathematics of Investment.